Welcome. This is the last class for shear reinforcement. First two classes I explained how to design using vertical stirrups. Previous class I explained the procedure when shear reinforcement is provided in the form of vertical stirrups, but when bent up or inclined bars are available for resisting shear. Now corresponding numericals. Actually, I am running little cold, so my voice is slightly choked. Helpless, we can't do anything. But I think it is manageable. Okay. Question 1. See, here also 3 questions. I will tell questions. First question, it will come unsafe. Then the bent up bar will not come into picture. Unsafe means unsafe, over. Second question, shear reinforcement is not required. When shear reinforcement is not required, those bent up or inclined bars, what is the use of that one? Somewhere not there, somewhere here. There is no use. Third question, shear reinforcement is required. Then it will come into picture. Same thing I did earlier also. Working stress also same thing. Limit state also same thing. 3 questions. Now, I will explain further as we go further. And one more thing, question 1 and question 2 are exactly same as the 2 previous questions we solved in class 2, that is design using only vertical stirrups. Exactly same. There inclined bars are not there or bent up bars are not there. Here bent up bars are there, but it won't take part. Therefore, question 1 and question 2 I won't explain much. You can refer the earlier part or you can refer working stress method. Refer everything for that matter. So, question is written here. I will start solution. See, solution for question 1, cross section considered 250 by 450, and it is told the cross section considered has 2 bars of 16 mm diameter as tension reinforcement at the top. Oh, that clearly means they told tension reinforcement at the top. So not required. Understood. Bending moment is hogging, but we don't require it. Remember, clear cover of 40 mm. So therefore, your D will be 450 minus 40 minus half of 16, 402 millimeter. AST provided for cross section, pi by 4 of 16 square into 2. Concrete given, steel given, and directly factored shear force given. Now, all these 3 questions, I will not give working load shear force because when I write something here, it takes more space. If shear force corresponding to working load or service load given, I have to multiply by gamma f and get factored values. I already told so many times in bending moment I told, earlier working test told, limit state recently told. So that you have to remember. As I told you, criminal offense. If the shear force or bending moment are given corresponding to service load, you have to convert it into factored load, corresponding to factored load. Okay, now that's why to save the time, it is not a concept for this class. Therefore, I am giving directly factored shear force of not 30 kilonewton, that was some other question. Sorry, factored shear force of 350 kilonewton. Oh, that is some other question. Okay. 350 kilonewton. Okay. I first read the question when tau V comes less than tau C. Then suddenly realized all these days in an order I am maintaining. What? First question unsafe, second question shear reinforcement not required, third is the critical question, shear reinforcement required. Among all these, starting from working test up to today, everywhere, see this is the fourth round you are doing problems. Question number 3 is the most critical. If question number 3 is fully clear, everything is clear. Okay, start. Required to design shear reinforcement in the form of vertical shear. Remember, even when inclined bars or cranked bars are provided, design is using shear reinforcement only. I will tell a small example. Design is using vertical stirrups only. Vertical stirrups is the main part. Without that, you cannot do anything. In that bent up bars, they are only supporting one. It is not main. Like deputy. See, chief minister, deputy chief minister. Chief minister is always chief minister only. So vertical stirrup is like chief minister. Deputy prime minister I will not tell because India has no deputy prime minister. So many states they have deputy chief ministers. But even then, chief minister is chief minister. Deputy Chief Minister may be there or may not be there. Okay, start. Required to design shear reinforcement in the form of vertical stirrups. Also given in the question. Okay, it's also given here. When, this is better. When two bent up bars of 12 mm diameter are available to resist shear, that is additional shear reinforcement. Class, this is only additional, it is not the main. Main is always vertical stirrups. Some extra support or extra help comes from this one. So remember, that's why IS code called vertical stirrups also shear reinforcement. These bent up bars are also shear reinforcement. I told you earlier, to differentiate them what to do, one suffix we will use. For vertical stirrups, ST, bent up bars or cranked bars, CR. That will come later. Okay, start. First, as usual, nominal shear stress. I told you, it is not this. Sorry, this I am telling for 10th time. Nominal shear stress means actual shear stress to be resisted 3.483. Class, this much shear stress cross section has to resist. Refer to IS code. See, inclined stirrup bars or bent up bars will come into picture only when you write shear reinforcement is required to be designed. Till you write shear reinforcement is required to be designed, this will be sleeping. It will not come. So never bother. Or previous class, I have your procedure for you. Okay. From IS code, table 20, for M25 concrete, tau C maximum 3.1. Oh, problem. Why? Shear stress is 3.483, but its limit is 3.1. IS code told if the shear stress exceeds the limiting value or tau C maximum, cross section is not safe. Not safe. Plus, therefore, cross section is to be redesigned. So, question 1 over. Not safe, it is to be redesigned. How to redesign? That will not come in the picture. But little I told earlier, go back earlier classes and check it. Now, over. See, question 1 over. Now, just for information in the class, somebody will question. Okay, sir, everything is clear now. But in the question they are given, what two bent up bars are available. You are not considered. What bent up bar? Nothing. Building collapsed. When the building collapsed, you don't go inside and tell one of the beam is good beam, one is a bad beam, one extra step for the beam I put more reinforcement there. You cannot tell all those things. Building collapsed. Therefore, no discussion. Collapse means collapse only. So, I told you this, where is it? Bent up bar, it will come into picture only when you write shear reinforcement is required to be designed. Then you use this strength. Okay. Therefore, question 1 completely over. I will go to question 2 now. Okay. Question number 2, I already changed the question. See, rectangular section of RC beam, 200 by 500, 200 by 500 is subjected to factored shear force of 45 kilonewton. Then the cross section considered has 2 bars of 20 mm diameter as tension reinforcement at the bottom. They told tension steel is at the bottom, means sagging beam. So 2 bars of 20 mm at a clear cover of 40 millimeter. So D will be 500 minus 40 minus 20 by 2. These are all mechanical. AST, pi by 4 of 20 square into 2. I told M20 concrete, correct? Because some people will start complaining. You wrote M20 there, here M20 concrete and FP415 steel, factor shear force 45 kN, required to design shear reinforcement, same question, using vertical stirrups. When the question is there, design shear reinforcement using vertical stirrups, when 2 bent up bars of 16 torr are available for resisting shear. Last time to 12 torr I told, this time to 16 torr. This time also it does not matter. See, additional steel. Okay, first nominal shear stress, tau V, VU by BD, substitute. You get 0.5 Newton per mm square. M20 concrete, table 20, tau C max, 2.8. So tau V, So I will change it. Okay. Tau v is less than tau c maximum. Therefore, safe. Class, if you want, shear stress to be resisted 0.5. IS code has given the maximum limit of 2.8. Okay, safe. Over. Proceed further. Last time question stopped here. Now proceed further. Next you require tau c. See the procedure. Actually 4 times you are doing it. Not 4 times. Each time 3 question. So this is the question number 13, 14, 15. If you consider working stress method. Allowed shear stress for concrete without shear reinforcement. IS code termed it as what? Design shear strength of concrete without shear reinforcement. For that you require percentage of tension reinforcement provided, PT provided, 100 AST by BD, calculate, it comes to 0.698. Refer table 19, M20 concrete, for PT 0.5 and 0.75, you get the value from IS code, interpolation, you get 0.543. Compare, tau V, actual shear stress is 0.5. Concrete alone can take 0.543. Means the stress is within that value which concrete alone can resist. So no help required. So shear reinforcement is not required to be designed. Therefore, I write here, therefore provide nominal or minimum shear reinforcement. At what spacing? At maximum permissible spacing as per IS code. Why? You do not want to waste the steel. Okay, now question I am not removing. I will do one thing. Last part I will write here, so that if I rub it, I can put the sketch once again, because already the sketch has become little, what I can call, not that one. Some ink marks are there, so I write fresh now. So last start. See, I told you provide nominal. How? Decide it. I write here. Let us provide two-legged 8-tor vertical stirrups at maximum permissible spacing as per IS code. 1 minute. Check the camera. Should not go out of camera. Okay, within the camera only. Okay, now go to IS code. Again, somebody may ask, sir, what about that cranked bar? No. First of all, shear reinforcement is not required. When not required, when help is not required, somebody will tell, I also will help. You tell, I don't require help. You come when help is required for me. Okay. IS code. See, no space right here. Maximum permissible spacing for vertical stirrups. Space problem. Maximum permissible spacing for vertical stirrups is 1, 300 millimeter. Second one, 0.75 D equal to 0.75 into D is 450 millimeter. That is, see, 0.75 into 450. 337.5 millimeter. Then third one, ASV into 0.87 FY divided by 0.4 B. IS code condition Fy is not to be taken more than 415 Newton per mm square. Right here. Our Fy is 415 only. Therefore, substitute 415. But the next question, I am giving Fe 500. At that time, you should not substitute 500. You should take 415. Okay, start. Again, no space problem here. ASV, right here. Those who want write, cross-sectional area of the legs of the stirrups equal to pi by 4 of diameter square into number of legs equal to pi by 4 of 8 square into 2 is ASV into 0.87 into 415 divided by 0.4 into, what is the width? Width is 200. Pi by 4 of 8 square into 2, then into 0.87 into 415 by 0.4 divided by 200. 453.71. Those who want right here, of all this value, whichever is least value, Therefore, maximum permissible spacing as per IS code is least of all 300, 337.5, 453, 300 millimeter. Therefore, provide two-legged 8-tor vertical stirrups at 300 millimeter center to center as per the IS code requirement. Practically, what they will make is they will remove the 200, will make it 250. Some people even make 200. That is their problem. But you can give. Should not give more than 300 spacing. Okay, now question 2 is completely over. Once again, make a note. Those two cranked bars are not considered here also because shear reinforcement is not required. Now, the most critical question, everywhere, see, working stress method with only vertical stirrups, question number 3. With the cranked bars, question number 3. Limit state, previously uploaded with only vertical stirrups, question number 3. Even now also, question number 3, that is a master question. Okay, that I will solve in front of you only. I won't write it, but up to here I will prepare. Why? Up to tau V and tau C I will prepare. That shear reinforcement part I will write in front of you. Now, question number 3, the most important question. Actually, this is the question which will cover everything. Start. A rectangle section of a RC beam, 300 by 600, 300 by 600, factored shear force of 360 kilonewton. I written here 360 kilonewton. Factored given, tension side 3 of 25 torque. This time I told effective cover at the bottom. This is D. So 600 minus 50 is D. AST you can calculate. I told there M30 concrete. I changed it. Yes, M30 and FE500. M30, FE500. Required to design shear reinforcement in the form of vertical stirrups when 3 bent up bars of 16 torque. Now, how those bars are available, where those bars are here. See, 1 minute now. I will show some stirrup here just to understand. Vertical stirrup. Where those bars are, see, it may be here, it may be here, it may be here, depending upon when the bars are coming this way, where you cut cross section. But for structural design, it is there, given in the question. So that's all I can tell here. I cannot once again explain how the bent up bar will come because my liability here, my purpose here to see that design part is clear. Okay, now I do one thing now. To understand correctly, see, the bent up bar, I will use green color. This is a new guest now, remember, guest appearance. You remember, some extra help is available if required. Okay, I will use green color. Start. First, mechanically as usual, nominal shear stress tau V, Vu by BD, 2.182 will come. M30 concrete, tau C max 3.5, tau V less than tau C maximum, therefore safe. Okay, then to get tau C, that is allowed shear stress for concrete without shear reinforcement, same 100 AST by BD calculate, go to table 19, get the value, you get 0.630. Okay, now full question board I will remove and start fresh from here. Remember, I will tell you, when I start fresh, I noted down the values required for me. This is not for you. Don't see that one. Because to save the time, I noted down all the values here. See, I remember B, 300, small d, 550, tau V, 2.182, tau C, 0.630, 3.16. What is 3.16? I don't know what is 3 of 16 torque available for so on. Then other numbers I calculated. You don't worry about it. Other numbers will come now. You never see anything. You make your own fair copy. Full board I will rub. Everything I will solve in front of you now. But only thing is calculation, I already done it to save the time. Continue. Next step. Compare. I told, see, we already got tau v and tau c. Next step is what? Therefore, compare tau v with tau c. Okay. Tau v you got 2.182. Tau c you got 0.630. So tau v is more than tau c. If you want class, how much shear stress is to be resisted? How much shear stress concrete alone can resist? Oh, this time shear stress to be resisted is more than capacity of concrete. Therefore, what you have to write? Shear reinforcement is required. Required to be designed. To be designed. Right. One note you can write here. Note. Now those cranked bars will come into picture. Now you require help. Now the cranked bar will suddenly become active. Okay. But do one thing required. First you propose vertical stirrups. Let us provide two-legged 8-tor vertical stirrups. Vertical stirrups. This is usual stirrups. Then you have to find the spacing as per IS code. Spacing of vertical stirrups. Spacing of vertical stirrups. Stirrups, that is SV, remember, based on strength. This is very, very important. 1000 times I told. Strength equal to 0.87 Fy into ASV into D divided by VUS. Now, see, this is the formula for spacing for vertical stirrups. See here, where I write ASV is cross-sectional area of legs of stirrups equal to pi by 4 of diameter square into number of legs, or equal to pi by 4 of 8 square into 2 will become 100.53 mm square. Okay, now this over. VUS is ultimate or factored shear force to be resisted by vertical stirrups. Very important now, vertical stirrups. How to get VUS? VUS equal to whatever VU subtract VUC. This was the formula earlier. When inclined cranked bars are not there, this is a procedure. Whatever shear force subtract shear strength of concrete. But now we got cranked bar is there, so you have to subtract also minus VUS. Oh, problem comes. This is VUS for stirrup. This is VUS for cranked bar. Confusion. So what I will do? VUS CR. So I will do one thing now. This I will call VUS ST. See, I told earlier. See, working stress method. Therefore, formula will change VUS ST and ASV ST, because one more ASV will come. So ASV ST is stirrup. One extra. This all I told, working stress method, so thoroughly explained. So limit state, I again already given procedure. Now follow it. Start one by one. First VUC. VUC is ultimate shear strength of concrete, or how much shear force concrete alone can take, equal to tau c into BD. Calculate first. Tau c. Where is tau c? 0.630 into B is 300 into 300 into D is 550. That will come 103.95 10 to the power 3 Newton. Okay. Now, VUS you require. But before that one, remember, as per IS code, Fy is not to be taken more than 415 Newton per mm square. Remember, for both vertical stirrups and also cranked bars. And also cranked bars. CIS code, right here. Therefore, one statement, you write for Fe 500 steel, Fe 500 steel, Fy equal to 500 Newton per mm square. But considering IS code condition of Fy not more than 415 Newton per mm square, consider everywhere, consider Fy equal to only 415 Newton per mm square, okay, mm square for both vertical stirrups and also later for cranked bars. Okay, over. Now, VUSCR you want, see. I write here. VUSCR is ultimate shear strength of cranked bars. Either cranked bars or bent up bar or inclined bar of cranked bars. CIS code, they told it. VUSCR, they told only VUS there, equal to 0.87 Fy into ASV for cranked bar into sin alpha. Again condition, what is the condition? Fy not to be taken more than 415 Newton per mm square. Okay, ASV, same color. ASV CR is cross-sectional area of cranked bars equal to pi by 4 of 16 square. They told 3 cranked bars are there, correct no? I think 3 cranked bars, yes, correct, right there, given in the question. 3 bars of 16 torr available, therefore into 3, 603.19 mm square. Great. Alpha is, no space right here, angle of inclination of cranked bar with axis of the beam. Take alpha equal to 45 degrees. You write it, 45 degrees in absent data. Substituting VUSCR equal to, I'll use 0.87 into 415 into 603.19 into sin 45 equal to, I already calculated, where is it? 153. I use same color. 153.99 10 to the power 3 Newton. Correct? 153 point. Let me check it, because I do not want any mistake of sometimes somebody telling calculation wrong. Okay. 0.87 into 415 into 603.19 into sin 45. Correct, 153.99 10 to the power 3 Newton. Now, very, very important. See, right here. Do not blindly substitute this value. Do not blindly substitute. There is an IS code condition. This is a very important condition. I write the condition as per IS code first. I explained thoroughly in working stress method, but once again let me state in the procedure I told. So this time briefly, procedure I give an example also. Where is the condition? 1 minute. Page number is a problem for me. See, I am very weak in page number all. Yes, correct. As per IS code, when bent up bars bent up bars, that is cranked bars. Cranked bars are provided are considered, that is much better, considered as shear reinforcement, that is a better word. Their contribution, see, that's very important, their contribution towards shear, what else? Towards shear resistance, okay, shear resistance shall not be taken, it is not given taken there, taken more than half of that of total shear, half of what? Half of, they told total shear reinforcement means half of total strength of shear reinforcement. This is a condition. This condition I explained in working stress method, and with the practical example I told something there including money matter, go through it. Then I told you simple procedure. This is, so many people will tell, sir, not clear, sir, confusion. Okay, then I told them, for this one you go for simplified version. I will remove all this one now. I will remove this one. I think I remove, yes. This value I required. Okay. I will remove this one now. Or you can write here after this one. That is, see, in simple words or simple way, what you can tell is, in simple way you can tell VUSCR shall not be taken more than half of VU minus VUC, because VU is the factored shear force, VUC is the strength of concrete. Subtract, you get extra strength required. This is in cranked bar should not be taken more than half. This I already explained there, including money matter I told. So you should see once again, second time I can't tell same money matter. Right here. That is VUS, same color. Okay. That is VUSCR shall not be taken more than half of VU minus VUC. Where is VU? VU I forgot now. Where is VU value first of all? VU value is, I forgot, okay, no problem. I know tau V value, no? I can calculate VU value. How much tau V I got? 2.182 into 300 into 550. 360, okay. See, there is everything, I can do it. Into 360 10 to the power 3 minus VUC. Where is VUC? VUC. Where you calculate VUC? Somewhere here VUC. 103.95. 103.95 10 to the power 3. That is VUSCR not to be taken more than, get the answer. No, it's already there. 129.025 kilonewton. 0.25 kilonewton. 10 to the power 3 Newton. Now, very important. Right. Now, see, this is, you should not take more than that value. See, you already know the value of VUSCR. I'll remove this one now. 153.6. Now here. VUSCR calculated is how much? 129.025. No. 153.99 10 to the power 3 Newton. Okay, now tell me. Therefore, VUSCR to be considered for further design, to be considered is the most important to decide. See, what you do is, see the calculated value, see the maximum limit. Among these two, take whichever is least. Least is 129.025 10 to the power 3 Newton over. Because you should not take more than this value. Now, make a small note. By chance, make a small outside note. If only 2 bars of 16 torr are used, then instead of 3 bars, if only 2 of 16 torr are there, the value will be 102.66. Then you have to consider what? Then you have to consider not 129, you have to consider 102.66. Or why that much confusion? VUSCR to be considered is either VUSCR calculated value or VUSCR conditional value as per IS code among the two values, whichever is least over. Okay, now everything is over. I will write here now. See, everything over. Nothing required now. Nothing required. Okay. Substituting. What you want now? We actually want what? VUSST. VUS stirrup equal to 360 10 to the power 3 minus VUC. Somewhere I wrote here. VUSST equal to VUC. I written formula here. VU minus VUC minus VUSCR equal to VU 360. VUC is 103.95 minus VUSCR is 129 point, that color, that value, 129.025 outside 10 to the power 3. It will come once again 129.025 10 to the power 3 Newton. Helpless, but if this value is other 1 or 2, it will come different. Substitute. Okay, over. Substituting. Right here. Spacing of vertical stirrups. See, SV equal to 0.87. You should substitute Fy equal to 415. ASV for stirrup is 100.53 into D is 550 divided by VUSST is 129.025 10 to the power 3. You get the spacing of the stirrups. This is, remember, spacing strength based. Strength based spacing. Answer will come 154.72 millimeter. 154.72 millimeter. Okay. Now, lastly, what you have to do? Go to IS code for maximum permissible spacing. That always you have to do. Now, see. Now, right. Now we will go to IS code. Because before providing, so remember, this is strength based. As per IS code, maximum permissible spacing for vertical stirrups. See, short I am writing, you should write fully. Maximum permissible spacing for vertical stirrup is 300 millimeter. Second one, 0.75 into D equal to 0.75 into 550. Note it down. Yes, 412.5. Note it down. 412.5 millimeter. 3 ASV into 0.87 Fy divided by 0.4B. Which ASV? ASV for stirrup. Stirrup, that is 100.53 into 0.87. See, once again, Fy not to be taken more than 415. So into 0.87 into 415 by 0.4 divided by 300 equal to 302.47. 47 millimeters. Among all this value, whichever is least, therefore, maximum permissible spacing as per IS code for vertical stirrups is 300 millimeter. Right here. Spacing SV we got from strength is 154.72. Again least, therefore provide 2-legged 8-torr vertical stirrups at 154, round off 150 millimeter center to center. Okay. Question 3 completely over. From my part, design of shear reinforcement when only vertical stirrups used, and also when cranked bars are available, both working stress method, their 4 parts, limit state method also 4 parts, completely over. Now I will upload the last part, flexural analysis of T section, one of the most important for competitive examination and academic question, and practical knowledge also required. Okay, thank you.